Hello everyone, welcome to my shop. I'm Robin, and today we're looking at a repeatometer. I needed a repeatometer for working on the surface plate. I realized that I don't want to be dragging the rensometer around on not perfectly clean plate for doing repeat reading work while working on the plate. So I said, hey, let's do some stock rack engineering and let's make a quick and dirty repeatometer. In the process of that, I realized, you know what? This can be a real study in simplicity. And so that's what it turned into. It's just basically one piece. Yes, it's got 3 carbide feet, and it's got a screw holding the indicator, and it's got the handling knobs, one for sliding it around, one for picking it up. But other than that, it's a one-piece item with flexures. And I'll zoom in here a little bit, and we'll take a look at the flexures. This vertical flexure is 7 thousandths thick, and this was just milled with an 1/8 inch end mill, as you'll see in the video. Down here at the bottom, that's about, I don't know, 30 thousandths thick. This upper flexure keeps this stable such, if we just had this very narrow flexure down here at the bottom, you could easily take this tail piece here and twist it and ruin this flexure. By having this flexure up at the top, it gives it stability because it would have to shear this flexure sideways, which it doesn't want to do. And this is thin enough that allows the weight of this to have enough force to flex this flexure and drop significant amount, 5 or 10 thousandths on its own weight, so that it's not influencing the reading. This indicator is a Brown & Sharpe 599 981 indicator, and it's basically has infinite resolution because it's an LVDT. My meter that I have here can read to 1/1,000th per division on the lowest scale, and that allows us to get very, very good repeatability. Another feature of this gauge head is that its actual repeatability is 0.4 microinch, so 0.4 of a microinch repeatability. So it's capable of making this a very, very accurate repeatometer if we're trying to get down into, let's say, a 5/1,000,000ths repeat reading plate or 10/1,000,000ths repeat reading plate, which is what I'm going to attempt to do. So design-wise, this thing's very simple. A repeatometer is basically 2 stationary feet, a 1/3 hinged foot that is read by some kind of measuring device, and that's what we have here. By making this dovetail grab on the back edge of the indicator here, I can actually get this in the ballpark and then just snug this and gently tap it in to get the 0. And because I'm using an electronic indicator, I can electrically zero the last part, eliminating any kind of mechanics required for zeroing, which makes it a lot more stable. One of the critical elements for something like this with a flexure is a means to limit the travel so that this doesn't get forced too far up and exceed the elastic limit of either flexure or pulled too far down. So I thought about that for quite a while, and then realized just drilling a straight hole, 1/8 hole through the whole thing, putting a dowel pin in there while I do all my work, and then when I'm all done, I just took the pin out and ground a few thousandths off the diameter here so that as this pivots back and forth, it bumps into the pin both sides. It also provides a mechanical means of high stresses laterally on this, not overstressing this flexure sideways. So that worked out kind of neat. These are just plastic purchased knobs from McMaster-Carr, piece of all thread with some adhesive lined heat shrink on them, Loctited in place. One other feature that I wanted to incorporate is no basically, other than the wire ties, no mechanism for clamping these other than that slot. So I drilled a hole through sideways, milled in with a ball mill both sides, leaving it so that this was actually captive to restrain this cable, because we know that this cable could influence the indicator. And then on this end, where the indicator hits has been stoned nicely with the precision ground flat stone so that it is smooth and doesn't have any topography. And so this gives a super repeatable gauge. And yes, even though it's a very thin cross section, because I made the center leg stick out 3/8 of an inch on either side on this leg, and relieve the center of them so that it has a good stability. This repeats very, very well and is nice and stable. This really moves freely and is easy to manipulate on the plate. Let me back up here. This is very easy to manipulate, and it's stable and really glides nicely with the relieved feet. So as you traverse a repeatometer, it shows the up and down undulations of the plate, and representing what you might get if you were using a surface gauge measuring out at some point out here in space. And you can't expect to get readings that are more accurate than what your maximum repeat reading is on the plate. So that's what this gauge accomplishes. Hey, this thing's made out of one piece of material, and it's a tool. This could be an entry in the Spareroom toolmaking competition 2018. I'll post the detail to Emma's contest down in the notes.
Using my digital stop on the roll-in saw to cut the piece to length. Roll-in saw is very handy. Be my #1 recommendation for anyone in any shop. This is low carbon precision ground stock, 1/2x4 by 11 3/4, milling the ends, milling it to overall length.
Drilling all the holes from the face that's accessible from this side. Drawing sitting here, just doing manual on the mill. So the 3 press fit holes for the carbide pins, clamp screw for the indicator, this wire tie holes for strapping the clamp, and a starter hole for one of the milled slots.
Using an 1/8 ball mill to mill in the side grooves for the cable clamp, leaving the small rib in the center.
It's nice having a really tall mill where you can grab things like this and drill in the end of a part like this without a bunch of carrying on. Using a 10-degree angle block to set the angle for the hole that is the stroke stop hole.
I'm milling off the bottom of the base so that the carbide pins will be exposed enough to act as feet when I grind them down. Doing the first of the flexure cuts here on an 1/8 inch carbide 4-flute end mill at 4200 RPM, 3 inches a minute, doing 0.1 depth of cut per pass. So 5 passes I actually go through the whole 1/2 inch piece. This is the second flexure, and then I'm actually using it to just saw off the end there, the same 0.1 deep. Here I'm surface grinding just for finish and effect. That'll get stroked with 220 paper to get even smoother finish, more uniform. There you see the flexure.
Little chamfer micering of the edges.
One of my favorite activities, slotting on the Bridgeport. Very handy, allows you to do things that people would consider impossible. And even if I had a shaper, this would be easier here. This just allows me to put a slot in this design that is very effective, yet couldn't be machined easily with other methods.
Here's the rude and crude tool that I made just to get in there and do the dovetail. The 60-degree angle is done on the D-lip grinder and the cutting face, but then I relieved this so that I could get into one side by aligning the one face and then spin it and get the other side, lining up the other face, and then this is the clearance to clear the wall on either side. Indicating in the flank of the wacky tool I'm using to get in to do the dovetail.
Here I'm using my D-bit grinder to cut off carbide blanks to length. That's a 35 thousandths thick diamond cutoff wheel. Just works amazingly well. Really suggest you use super abrasive wheels on your D-bit grinders. Just really makes for quick work of cutting these things off. These are only sped up 2x what you're seeing here, so it's still extremely quick to cut through carbide. Now I'm using a 600 grit face wheel to chamfer the edges of the blanks so that they have a smooth edge. Now we're over on the grinder. I have the dowel pin in to hold everything together so it doesn't move, the stroke stop dowel pin. I have it blocked in with 1, 2, 3 blocks. Here I'm grinding off the actual foot height. I've already ground a groove axially in the center to split that center foot into 2 pieces, into 2 pads. And now I'm going down and actually doing the edge relief, just plunging down to get a sharp edge on there. I'm a fan of sharp edged feet that scrape dirt and gunk ahead of them instead of guiding it into the plate. Doing the same thing here, touching off and grinding the one edge of the foot to get a sharp edge. And grinding the opposite side of this foot, the center foot, because it's easy to go the same crank distance between the 2 edges. Getting a nice sharp edge on there. That's just a 1/2 inch wide diamond wheel from Schar's tool. Touching off on top here and doing the top surface of the other foot. I've flipped the part around end for end. It looks like it's the same foot, but it's actually the other end of the part with a knob. So I'm grinding the foot height, and then I'll do the edge reliefs on this end also. So here we're dropping down a little closer, and you can see I'm using the edge of the wheel to generate a sharp edge. I don't want that 45-degree blend there, because that just encourages stuff to roll under the feet instead of getting squeegeed off by the sharp edge. Now we'll come around to the back side so we can see using the opposite edge of the wheel to do the other edge of the foot. There's the axial relief I talked about.
So I just happen to have a lap handy. Take a look and see what's going on here. Oh, lovely. And I can tell when things are done because the grind lay is this way, is this direction on the grinder, and my lay on the lap is the other direction, so I can actually see as things wear in. And I'm going to actually change directions here and use this. Okay, let's take a peek here and see what we've got. There you can see the lap. The lay of the lap is longitudinal, where my grind marks were this way. The lay is this way. Same way on this end, and obviously putting these on plates that you're lapping with diamond, these are going to self lap, but that's all it took to get the grind marks off of there and get good sharp edges on that. So here's the topography of the feet. You can see we've relieved them because they have sharp edges on all sides. Here's the center feet. You can see the lap, the surface, same thing, sharp edges. And the last foot, there's some smears and stuff on there, but these are going to self lap in as it rides on the plate. So that's just an easy way to press fit carbide. It's an easy way to get carbide in there without brazing. Good and solid. It's a press fit and Loctited. So I went over on the D-bit grinder and just ground a few thousandths off of the pin here at the end where these moving part of the jaw rides in the same drilled hole that I drilled in the beginning. This is what gives us our travel limit from the theoretical just few thousandths that was left from the clearance in the hole. One of the things that can really set something apart as far as appearance is just the final touches that you do to a piece like this. If I just milled this and hand filed the corners and that was it, threw it together, it wouldn't have half the effect that it has now. By surface grinding it, which is a very quick way to get a nice uniform finish, that's a good start. Then I used my chamfering machine, Chamfermeister, to put nice uniform chamfers on. Very uniform chamfers are definitely something that is a sign of quality. It just stands out to people as something that just emits quality. Edge breaks always make things look a little bit more professional. Things like the lines having some kind of aesthetic appeal to them, flowing with the rest of the indicator, helps. One thing that I am a big fan of is rounding the chamfer intersections and then using abrasive sponges to give a very smooth, uniform roll over on all the edges. Then even with surface grinding, I take 220 grit paper and stroke this until all the surface grinder variations are gone, so it's a nice uniform finish. And then the final is the maroon Scotch-Brite with some WD-40 and a very uniform lay of stroke on there on all the surfaces. Where you have your scratch lines, the lay of the scratches is very critical. Any little twist or whatever ruins the effect, and it doesn't take long. I probably spent maybe 15 minutes doing the cosmetic stuff on here, but that makes it the difference between it looking like just thrown together and looking like a really polished instrument. Edge quality here, just these things. These are the things that you need to pay attention to that make people really look at your work and go, wow. And all it is a little extra care. So I hope you've enjoyed this video, found something interesting or informative or useful. If you have, please subscribe, share with your friends, give it a thumbs up. Appreciate all your support, and I'll be back.